your entire AWS infrastructure from a configuration perspective. As well as using this service to act as a resource inventory, compliance checker, and manage configuration changes of your resources, it can also be used as a part of your security analysis procedure. Before we go any further, I would like to introduce myself. My name is Stuart Scott. I am one of the trainers here at Cloud Academy, specialising in AWS, Amazon Web Services. Feel free to connect with me with any questions using the details shown on screen. Alternatively, you can always get in touch with us here at Cloud Academy using the community forum, where one of our cloud experts will reply to your question. This course will be beneficial for people who are responsible for managing resource configuration changes within an AWS cloud environment. Also, auditors who must have an awareness of all AWS infrastructure and their current configurations and compliance, as well as security engineers who are responsible for implementing AWS security and analysing logs and identifying weaknesses and breaches to their environment. Throughout this course, we are going to be taking a deep look at AWS Config, and as a result, the following areas are going to be discussed. Starting with what is AWS Config. Within this lecture, we will understand exactly what the service is and what function it provides. Next, we'll take a look at key components. This lecture breaks down the service to allow us to look at all the components and their relationship to each other and the role they play as a part of the AWS Config service. Then we'll look at service integration. This lecture will look at how the AWS Config service integrates with other AWS services. Following this, we'll look at how to manage compliance with AWS Config. Here we will focus on how to maintain compliance using AWS Config, whether these be internal or external requirements or standards. And then finally, we'll look at some use cases and best practices. And this lecture will focus on some of the use cases of when it's best to use AWS Config to help you maintain, support and operate your AWS environment. On completion of this course, you will be able to recognise and explain how the AWS Config service can be used by AWS customers to monitor environmental changes. You'll be able to recognise and explain the core elements of the AWS Config service. You'll be able to confidently configure and implement AWS Config within your own environment. And you'll understand how to maintain compliance of your resources using AWS Config, for example, to help maintain security policies. Although you do not need to be an AWS expert to appreciate and benefit from this course, students will benefit from having a basic understanding of cloud computing and the AWS platform. So we recommend completing the What is Cloud Computing course, along with the AWS Fundamentals Learning Path. A high-level awareness of the following AWS services would also be beneficial but not essential. Simple Notification Service, SNS, Simple Queue Service, SQS, Simple Storage Service, S3, AWS CloudTrail, and Identity and Access Management. Feedback on our courses here at Cloud Academy are valuable to both us as trainers and any students looking to take the same course in the future. If you have any feedback, positive or negative, it would be greatly appreciated if you could use the comment section found on the landing page of this course. That brings us to the end of this lecture. Coming up next, we'll answer the question, what is AWS Config? Hello and welcome to this lecture where we will talk about the AWS Config service itself, what it is and what it does. So let's get started. As many of you will be aware, one of the biggest headaches in any organisation when it comes to resource management of IT infrastructure is understanding the following. What resources do we have? What devices are out there within our infrastructure performing functions? Do we have resources that are no longer needed, and therefore can we be saving money by switching them off? What is the status of their current configuration? Are there any security vulnerabilities we need to worry about? How are our resources linked within the environment? What relationships are there, and are there any dependencies? If we make a change to one resource, will this affect another? What changes have occurred on the resources and by whom? Do we have a history of changes for this resource that shows us how the resource has changed over time? Is the infrastructure compliant with specific governance controls? And how can we check to ensure that this configuration is meeting specific internal and external requirements? And do we have accurate auditing information that can be passed to external auditors for compliance checks? Depending on the size of your deployment with AWS, trying to answer some of these questions can be very time consuming and laborious. Some of this information can be captured via the AWS CLI by performing a describe or list against a specific resource. But implementing a system to capture those results and output them into a readable format could be very resource intensive. And of course, this will only help you with a small piece of the puzzle. AWS is aware that due to the very nature of the cloud and its benefits, the resources within an AWS environment are likely to fluctuate frequently, along with the configurations of the resources. The cloud by its very nature is designed to do so, and so trying to keep up with the resource management can be a struggle. Because of this, AWS released AWS Config to help with this very task. The service has been designed to record and capture resource changes within your environment, allowing you to perform a number of actions against the data that helps to find answers to the questions that we highlighted previously. So what did AWS design AWS Config to do? Well, in a nutshell, AWS Config can capture resource changes. So any change to a resource supported by config can be recorded, which will record what changed along with other useful metadata, all held within a file known as a configuration item, a CI. It can act as a resource inventory. AWS Config can discover supported resources running within your environment, allowing you to see data about that resource type. You can store configuration history for individual resources. The service will record and hold all existing changes that have happened against the resource, providing a useful history record of changes. It can provide a snapshot in time of current resource configurations. An entire snapshot of all supported resources within a region can be captured that will detail their current configurations with all related metadata. Enable notifications of when a change has occurred on a resource. The Simple Notification Service, SNS, is used with AWS Config to capture a configuration stream of changes, enabling you to process and analyze the changes to resources. It can provide information on who made the change and when through AWS CloudTrail integration. AWS CloudTrail is used with AWS Config to help you identify who made the change and when and with which API. You can enforce rules that check the compliancy of your resource against specific controls. Predefined and custom rules can be configured with AWS Config, allowing you to check resources' compliance against these rules. You can perform security analysis within your AWS environment. A number of security resources can be recorded, and when this is coupled with rules relating to security, such as encryption checks, this can become a powerful analysis tool. And it can provide relationship connectivity information between resources. The AWS Management Console provides a great relationship GUI, allowing you to quickly see and identify which resources are related to any other resource. For example, when looking at an EBS volume, you will be able to see which EC2 instance it is connected to. And it does all of this and presents the data in a friendly format. This is a lot of incredibly useful data that can be used across a range of different scenarios, some of which we will cover later in this course. AWS Config is region specific, meaning that if you have resources in multiple regions, then you will have to configure AWS Config for each region you want to record resource changes for. When doing so, you are able to specify different options for each region. For example, you could configure config in one region to record all supported resources across all services within that region, and add a predefined AWS Managed Config rule that will check if EBS volumes are encrypted. In another region, you could select to only record a specific type of resource, such as security groups, with no predefined rules allocated. Some of you may be wondering, what if the service you want to monitor is not region specific, such as IAM? Well, in this case, there is a separate option to include global services, which IAM falls under. Now we have an understanding of what AWS Config is used for and what it does. In the next lecture, we will introduce the different components that make up the service, showing what each of them do and how these come together to deliver the service features. Hello and welcome to this lecture, where we will be taking a look at the components that make up the AWS Config service and the functions that each of them carry in delivering the service. To understand how to get the most of the service, it's important to understand how the service is pieced together and how it works. So let's start by identifying the key components. Following this, we will then break each of them down to understand their role and how they sit within the service. The following identifies the main components to the service: AWS resources, configuration items, configuration streams, configuration history, configuration snapshots, configuration recorder, config rules, resource relationships, SNS topics, S3 buckets, and AWS config permissions. Let's now take a look at each of these in turn in more detail, starting with AWS resources. As discussed in the previous lecture, AWS resources are typically classed as objects that can be created, updated, or deleted from within the AWS Management Console or programmatically using the AWS CLI or supported SDK. AWS Config records changes to supported AWS resources within a specific region. For the current list of supported services and resources, please follow the link on screen. A configuration item, or CI as it's known, is a key component of AWS Config. It is comprised of a JSON file that holds the configuration information, relationship information, and other metadata as a point-in-time snapshot view of a supported resource. All the information that AWS Config can record for a resource is captured within the CI. A CI is created every time a supported resource has a change made to its configuration in any way. In addition to recording the details of the affected resource, AWS Config will also record CIs for any directly related resources to ensure the change did not affect those resources too. For example, if there was a rule change to a security group, additional rules would be added with new ports. AWS Config would record all CI information for that resource, but it would also gather CI information for any instances that were a part of that security group. The CIs would then be sent to a configuration stream, which we will cover next. As so much data is gathered within these CIs, it's important we look at this in further detail. So for every CI generated, there will be 5 different sections. Firstly, metadata. This essentially contains details about the configuration item itself. So within this metadata, we have both a version ID and a configuration ID, which uniquely identifies the CI. In addition to this, other information include an MD5 hash that allows you to compare other CIs already recorded against the same resource, as well as ensuring there are no duplications. And then we have the time of the capture and state ID, which puts the CI for a particular resource into an order of sequence, which is useful when multiple CIs for the same resource are sent to the configuration stream. Attributes. This holds common attribute information against the actual resource. Within this section, we also have a unique resource ID and any key value tags that are associated to the resource. The resource type is also listed. For example, if this was a CI for an EC2 instance, the resource types listed could be the network interface or the elastic IP address for that EC2 instance. The Amazon resource name, the ARN, for the resource would also be shown along with the availability zone that the resource belonged to. Bear in mind that for services and resources that are not fixed to a particular availability zone, such as IAM and IAM roles, then this section would not be applicable. Lastly, the time that resource was created would also be given. Relationships. This holds information for any connected relationships that the resource may have. So within this section, it would show a clear description of any relationship to other resources that this resource had. For example, if the CI was for an EC2 instance, the relationship section may show the connection to a VPC along with the subnet that the EC2 instance resides in. Current configuration. This will display the same information that would be generated if you were to perform a describe or list API call made by the AWS CLI. AWS Config uses the same API calls to get the same information. So depending on the API call and resource, different information will be returned, which is resource specific. Related events. This relates to AWS CloudTrail. This will display the AWS CloudTrail event ID that is related to the change that triggered the creation of this CI. There is a new CI made for every change made against a resource. As a result, different CloudTrail event IDs will be created. This allows you to deep dive into who or what and when made the change that triggered this CI. A great feature allowing for some great analysis to be taken, specifically when this affects security resources. As you can see, the configuration item is a fundamental aspect of AWS Config when recorded changes made to a supported resource. Because it captures so much data, these CIs are used by other features and components of AWS Config, such as configuration history. CIs are used to look up all the changes that have been made to a resource. Configuration streams. CIs are sent to an SNS topic to enable analysis of the data. Configuration snapshots. CIs are used to create a point-in-time snapshot of all supported resources. Following CIs, let's move on to configuration streams, which was briefly mentioned a few minutes ago when talking about the configuration items. When a create, update or delete API call is made against a supported AWS config resource, as we now know, a new CI is created, along with additional CIs for any resources that were related to the original modified resource. These CIs are then sent to a configuration stream, and this stream is in the form of an SNS topic. However, this stream is also used by AWS Config to send information when other events occur, such as when the configuration history for a resource was delivered to your account, when a configuration snapshot was started and delivered to your account, when the state of your resource compliance changes against any config rules that have been configured, when evaluation begins for rules against resources, and when AWS Config failed to deliver notifications to your account. This SNS topic can have different notification endpoints, such as email, or an endpoint more commonly used is SQS, Simple Queue Service. This allows the information to be accessed programmatically to then analyze the data captured. However, you could, like I mentioned, set up your email notification for all stream items. Although in a large corporate environment, this may not be ideal as your email inbox would get full up very quickly. If you do decide to do this, then it's worth setting up an email filter to ensure the information you're interested in is made available to you. More information on this configuration can be found on this link here. This stream for AWS Config should not be confused with the real-time streams that are available through the AWS Kinesis service, which continually capture huge amounts of data from multiple sources such as click streams, transactions, social media feeds, and IT logs, etc. The configuration history uses configuration items to collate and produce a history of changes to a particular resource. This allows you to see the complete set of changes made to a resource over a set period of time. The information can be accessed either programmatically through the AWS CLI using the following command. You can also specify the resource type. So for example, if you wanted to look at the configuration history for a subnet, you could enter the following into the AWS CLI. Or you could access the history via the AWS Management Console. Additionally, AWS Config also sends a configuration history file for each resource type to an S3 bucket that is selected during the setup of AWS Config. This configuration file is typically delivered every 6 hours, and like I say, it contains all CI changes for all resources of a particular type. For example, there would be one configuration history file covering 6 hours for all RDS DB instance changes in one region. The configuration snapshot also uses configuration items in its production. The configuration snapshot will take a point-in-time snapshot of all supported resources configured for that region. It will generate CIs for each resource in your AWS account for a specific region, and this configuration snapshot can then be sent to an S3 bucket. Alternatively, this information can be viewed via the AWS Management Console. Now let's take a look at the configuration recorder. So this component of AWS Config can be seen as the engine of the service. This element is responsible for recording all of the changes to the supported resources within your account and generating the configuration items. By default, the configuration recorder is automatically enabled and started when you first configure AWS Config. However, it is something that you can stop and then restart again at a later point. When you stop it, AWS Config will no longer track and record changes to your supported resources. When you first configure AWS Config in the AWS Management Console, you are asked which resource types you would like to record. This is essentially setting up and creating the configuration recorder, as this information is required to enable the configuration recorder to start. If you only select to record specific resource types, then it will capture all creates, changes and deletes for those resource types and will create a CI record for each occurrence. However, the configuration recorder will still record all creates and deletes of supported resource types within that region, but no changes to those resources will be recorded. Also, if you stop and change your configuration recorder settings to perhaps remove certain resource types from being recorded, then all captured information for those resources up to that point will remain, and you will be able to view their history with all data from the previous CIs that had been captured. AWS config rules are a great way to help you enforce specific compliance checks and controls across your resources and allows you to adopt an ideal deployment specification for each of your resource types. Each rule is essentially a Lambda function that, when called upon, evaluates the resource and carries out some simple logic to determine the compliance result with the rule. Each time a change is made to one of your supported resources, AWS config will check the compliance against any config rules that you have in place. If there is a violation against these rules, then AWS config will send a message to the configuration stream via SNS and the resource will be marked as non-compliant. It's important to note that this does not mean the resource will be taken out of service or it will stop working. It will continue to operate exactly as it is with its new configuration. AWS config simply alerts you that there is a violation, and it's up to you to take the appropriate action. These rules can be custom defined or selected from a predefined list of AWS managed rules that AWS has created on your behalf. Being able to create your own rules allows you to adopt best practices that you may have internally within your own enterprise or with other security best practices. By allowing AWS config to monitor resources at this level, it adds another level of automation, helping to prevent misconfigurations made by human error being left, which could lead to a security risk or, even worse, a breach. I highly recommend using config rules for maintaining security checks and configurations. AWS have a number of predefined rules that fall under the security umbrella that are ready to use. For example, RDS storage encrypted. This checks whether storage encryption is activated by your RDS database instances. Encrypted volumes. This checks to see if any EBS volumes that are in attached state are encrypted. Optionally, you can specify the ID of a KMS key to use to encrypt the volume. Root account MFA enabled. This checks whether your root account of your AWS account requires multi-factor authentication for console sign-in. IAM user no policy check. This checks that none of your IAM users have policies attached. Best practice dictates that permissions should be provided via roles or groups. The great thing about these predefined rules is that you can also edit them to make subtle parameter changes as needed. As you can see, being able to ask AWS config to check your resources' compliance with rules such as these are invaluable. And when you couple this with being able to create your own custom rules, the scope and potential of automating compliance is huge across your supported resources. When you first use AWS config with a set of rules, whether they are predefined or custom, don't be surprised by the results that you find. It's likely that you will see more resources being flagged as non-compliant than you may have imagined. As I have already mentioned, these config rules are great as a security tool to help you mitigate potential security issues that may arise within your environment. These config rules are also a great way to help you meet specific compliance and governance controls for auditing. You can currently use 50 config rules per region. However, if you are finding that you require more, then you can request an increase via AWS. Coming up later in this course, we shall have a demonstration on how to set up custom config rules, where I shall talk more about the different options available. As a part of the CI for a particular resource, for example an EBS volume, AWS config identifies relationships with other resources from that resource. In this case, it might be the EC2 instance that the volume is attached to. This allows AWS Config to build a logical mapping of resources and how they connect. This mapping of relationships allows you to quickly jump to other linked resources within the AWS Management Console to view their configuration history and CI data. This is very useful if you're trying to troubleshoot an issue and pinpoint where the source of an incident may be. For a full listing of available relationship types, see the link on screen. As we have already seen, an SNS topic is used as a configuration stream for notifications of various events triggered by AWS Config. You can have various endpoints associated to the SNS stream. Best practice indicates that you should use SQS and then programmatically analyze the results via SQS. The S3 bucket that was selected at the time of configuration is used to store all the configuration history files that are generated for each resource type, which happens every 6 hours. Also, any configuration snapshots that are taken are also stored within the same S3 bucket. The configuration details used for both SNS and S3 are classed as the AWS Config delivery channel, by which data can be sent to other services. When setting up AWS Config, you are required to select an IAM role. This role is required to allow AWS Config to obtain the correct permissions to carry out and perform a number of functions. For example, AWS Config will need read-only access to all the supported resources within your account so it can retrieve data for the configuration items. Also, we now know that AWS Config uses SNS and S3 both for streams and storage of the configuration history files and snapshots. So AWS Config requires the relevant permission to allow it to send data to these services. That now covers the key elements of AWS Config, and so I hope it makes it clear as to how each part plays a role within the service. To reiterate, let's take a bulleted point look at how it all comes together. When you first turn on AWS Config, you will configure the elements required for the configuration recorder to begin capturing and recording data. AWS Config will then discover all your supported resources based upon the details entered within the configuration recorder within that region. When a create, change or delete against a resource is made, a CI will be created for this change and a notification will be sent to the configuration stream regarding the new CI. Also, following this CI, AWS Config will check its current config rules to evaluate if the change has made a resource non-compliant. If the evaluated state changed for the resource, a notification will be sent to the configuration stream. Your config rules can also be configured to run periodically, and so they will run at a set given time period regardless if there have been any changes to resources. If a configuration snapshot is taken, AWS Config will create a point-in-time snapshot of the resources with new CIs and deliver this configuration to your specified S3 bucket within the configuration recorder. After 6 hours has passed from turning on AWS Config, a configuration history file will be created for each resource type and again sent to your specified S3 bucket. The configuration file will be sent every 6 hours from that point. Now we have learnt the theory behind AWS Config, let me introduce you to the service with a demonstration. In this demonstration, I will run through how to set up AWS Config, pointing out components such as the configuration recorder along the way. We will also look at the AWS Config dashboard, showing the timeline of events and how by using relationships of your resources, you can navigate through your infrastructure. During this demo, I'll also show you the configuration history file within S3. Okay, so I've just logged into my AWS account and I'm going to go up to services and you can see that AWS Config is under management tools. So if we select config, and this is the first splash screen you'll be presented with if you don't have AWS Config started as yet. So let's get started by clicking on the Get Started button. And then there's 3 steps to setting AWS Config up. So the first step is configuring the settings. And as I mentioned earlier in the lecture, we have our resource types to record. And this is where we essentially start the configuration recorder by identifying what resources we would like included in our AWS Config configuration. So starting from the top, we can either select all resources, within this region, remember AWS Config is region specific, so we can choose to record all the resources supported within this region. And currently I'm in the London region. And we can choose to include global services like we also discussed, services such as IAM, etc. But for this demonstration, we'll just choose to record all resources in this region. Here you can select specific types if required. So if I untick this, we can then go down to this drop-down box and select specific resource types that we'd like set up for this configuration. So you can be quite specific, selecting your load balancer or different elements of IAM, and again different elements of RDS, etc. So there's a list there that you can go through to if you just want to record a specific resource type. But like I said, for this demonstration, I'm just going to select all resources. Next, we need to define our S3 bucket, and this is where our configuration history and snapshot files are stored. So we can ask AWS Config to just create a new bucket for us, and it'll prefix it with this bucket name here. Or we can choose an existing bucket from my account by selecting the drop-down list, or we can select a bucket from another account. So if you had multiple accounts, you can send the configuration history files and snapshot files for all those accounts to a single primary AWS account in a single bucket. So for this example though, for this demonstration, I'm just going to ask AWS Config to create a new bucket for us. Config bucket Cloud Academy. Now moving down to the SNS topic. Now this is the configuration stream as we discussed. So for any events that AWS Config picks up, it will send it to this SNS topic for the configuration stream. Now we can create a new topic, and again AWS Config will just give us a topic name here, or we can select to choose another topic from your account, or again from another account. For this demonstration, we'll just ask AWS Config to create the topic name for us. And I'll just add in Cloud Academy. Now finally we have the AWS Config role, and this is where we spoke about the different permissions, and this is required to allow AWS Config to send the configuration history file and snapshots to S3, as well as having access to send events to the SNS topic. And not forgetting enabling AWS Config to be able to kind of go out and poll your resources as a describe or list API call to get the details of those resources. And again, for this demonstration, I'm just going to ask AWS Config to create a role for us. I'll just hit Cloud Academy on the end. So that's setting. So this screen is essentially your configuration recorder. By setting this up, you're asking AWS Config to start recording. We have set up the S3 bucket to allow our configuration history files and our snapshot files to be captured. And we have created our configuration stream by configuring an SNS topic. And we have also allowed AWS Config to have the necessary permissions to carry out those functions. So once that's all set up, we'll click on Next. And here we have a set of predefined AWS managed config rules. And like I said earlier, this is a number of templates that you can select to check the compliance of your resources against these rules. We'll cover more on AWS config rules in a later lecture, and we'll also have a demonstration on how to create one and modify one of these existing AWS managed rules. So for now, I'm just going to click on Skip. And here we're on the final stage, which is review. So we can see here the resource types we've selected, which are all resources, and we've not chosen to include global resources. We have our S3 bucket set up for our history files and snapshots, and we have our SNS topic for our configuration stream configured, and we have the permissions given by the AWS config role. And that's essentially the elements to setting up AWS config. So once you're happy with that and once you're done with that, you can click on confirm, and you can see that it's now setting up AWS config for this region. And that's it. It's set up and it's running. So whatever create, deletes or changes I make to supported resource types within this region, AWS config will now begin to monitor that and record it and log it within the configuration stream and also within the configuration history files. Now what I've done, I've already set this up in another region and I've made a few changes. So what I'll do now, I'll swap to that region and we can take a look at some of the other elements such as the configuration history file, the timeline of events, etc., and look at how the relationships are set up within this dashboard. So let me swap over to another region, which is Ireland. So as you can see, I've just swapped to the Ireland region and we don't have the option of setting up AWS config because I've already set it up and you only have it running once within the region. So let's take a look at what we have here. Straight away we can see that I've had existing rules. I had a rule name of S3 bucket versioning enabled. So I wanted to check if my S3 buckets had versioning enabled. So this is one of the config rules. So if I just open that up, I can see that a number of these buckets do not have versioning enabled and they have been marked as non-compliant. Now remember, I can still use these buckets, I can still write to the buckets, I can still delete objects from those buckets. It's just notified me that these buckets are non-compliant with this specific config rule, which is to check if, well, it says here, it checks whether versioning is enabled for your S3 buckets. Now let's have a look at some of the other resources that we have. So I can filter on a specific resource type that I want to take a look at. So let me take a look at my VPC. Let me look up everything to do with my VPC. So I can see here that I have two VPCs and let's take a look at one of them. And this has now taken us to the timeline of events of these VPCs. So on the 15th of March at 11:25, there was a resource discovery. So that's probably when I activated AWS config within this region and it went out and done a discovery of all resources. And then at 11:32, there was a change on this resource item. So let's take a look at the rest of the page. So one of the configuration details, we have a number of details here. We have the Amazon resource name, the resource type, the ID, the CIDR block of the VPC. So there's different configuration details that we can see for different items. Now we can also see the tag name here, which is CA demo. And further down we can look at the relationships. So this will show other resources that have a direct relationship with this VPC. So we can see we have a couple of network ACLs there. We have an internet gateway, we have some route tables, security groups, and some subnets. So each of these resource types has a direct relationship with this VPC. And if I wanted to, I can select straight from here to click on that network ACL, and it will take me to the details for that ACL. And again, we have some resource type information here, the ARN and the ID, etc. Again, if we click on the relationships, we should see the VPC that we just come from. So let's go back to our VPC. So as you can see, it's very easy to look at the relationships between different resources and navigate between them. And it's kind of grouped in a logical manner to allow you to quickly get between the different resource types that you'd like to. Now we can see up here that on the 15th of March, 11:23, there was a change. Now if we go down to our changes here, we can have a look at what that change was. We can see it's defined by two different categories, a configuration change or a relationship change. We can see that by the number that this change was to do with relationships. And it looks as though a new subnet was added to this VPC. And then finally we have our CloudTrail events, and this will capture any API calls that made changes to resources. However, it will only capture these for the previous 7 days. So because this change was made on the 15th of March and it's now the 30th of March. So if we look at the CloudTrail events, there's nothing there, they have expired. So what I'll do, I'll go and make a couple of changes. I'll create a new subnet within this VPC. So I'll pause the video, wait a few minutes, and then I'll start it again and we can analyze the CloudTrail event of that new change. Okay, so I've gone off and I've created a new subnet within this VPC. So we can see that the 30th of March, which is today, that there was a change that occurred and two new events. So let's go ahead and take a look at the change. So we can see that there is a new subnet. This is the subnet that I just created. And if we look at the CloudTrail events, we can see that we have the creation of the new subnet there. Now, if we click on the actual CloudTrail event itself, it will take us to CloudTrail and we can look at additional information. So now we're looking at the details of the API call itself, and we can see a number of different information here. We can see the user that created it, the source IP address, the time, the event source, and also the region as well, along with any affected resources as well. So here we can drill down into exactly what time it occurred, as you can see up here, the date and time, and by who and what event actually was created. So as you can see, clicking on that CloudTrail event, you can get additional information to kind of help you with resolving incidents and looking at potential security breaches to try and gather more information as to identifying who is doing what and when. So now let's take a look at the configuration history, which is stored in S3. So let's go across to S3. So if I go to the bucket that I use for the island region and then navigate through the folders to the correct date and time of today, you can see the configuration history folder. And then if I download one of these files and then open that, we can see here that that configuration history file contained the subnet creation that we just created for our VPC, and it shows you all the different information about it, the availability zone, the CIDR block used, etc, etc. And there's the subnet ID, and it also highlights the relationships to other resources for that new subnet, such as any network ACLs that may be associated. So that's the configuration history file that's stored in S3 in a JSON format. That brings us to the end of this demo. So we looked at how to set up AWS config for a region. We then looked at the details of a specific resource type. We looked at the VPC and how the timeline of events work. We looked at a couple of changes and also the CloudTrail event logs as well. And then finally, we looked at one of the configuration history files as a JSON document. That brings us to the end of this lecture. Coming up next, we will look at how AWS Config integrates with other AWS services in a bit more detail. Hello and welcome to this short lecture on AWS Config Service Integration, where we shall look at the relationships between AWS Config and other AWS services. AWS Config has a specific relationship with the following AWS services: SNS, SQS, S3, CloudTrail, and IAM. Let's start by looking at SNS. We have already covered much of this in the previous lecture, where I explained how SNS is used as the configuration stream for CIs and other important event notifications. By using SNS, you can subscribe multiple different endpoints to the SNS topic created as a part of your configuration recorder information to extract data and process information, and this is where SQS comes in. If you had multiple accounts, you may want to have AWS config in each account subscribed to the same topic in a primary AWS account. This is possible by allowing access of the service principal to publish to the same topic in the primary account. See the permissions for the Amazon SNS topic within the following AWS developer guide for a sample policy on how to do this. The Simple Queue service, SQS, can be subscribed to the AWS config topic, the configuration stream, which gives you a highly available and decoupled environment for the data within your configuration streams. By using SQS, it allows you to create and use your own applications to extract only information and data that is pertinent to you. There can be vast amounts of data coming into the configuration stream, but you might only want to be notified and made aware of any changes that may relate to any potential security issues. As a result, you may want to pull information from the queue that only relate to security groups, NACLs, IAM roles, etc., or any other resource type that could affect the security of your environment. If you did decide to have different configuration streams in each region, so effectively different SNS topics, then you could still subscribe the same SQS queue to multiple SNS topics, preventing your application from polling from multiple queues to process data from the configuration stream. S3 is used to store the configuration history files and any configuration snapshots of your data within a single bucket. And again, this bucket is defined within the configuration recorder. You can get AWS Config to create a new bucket for you or select an existing bucket. If you have multiple AWS accounts, you may want to aggregate your configuration history and snapshot files into the same S3 bucket for your primary account. However, you will need to grant write access for the service principal, which is config.amazonaws.com, to be able to write to the S3 bucket. Take a look at the section granting AWS Config access to an Amazon S3 bucket in another account within the following link for a sample policy on how to do this. AWS CloudTrail interacts with AWS Config at the configuration item level. If you remember back to the section in the previous lecture, the CI is comprised of 5 different sections. The final section, Related Events, displays the AWS CloudTrail event ID that is related to the change that triggered the creation of the CI for that resource. This feature is very useful when identifying who or what made the change to the affected resource. This CloudTrail data can be accessed via the AWS Config dashboard within the AWS Management Console, which will then link you directly to the event within CloudTrail. For more information on CloudTrail, we have a course, AWS Config An Introduction, that will define exactly what the service is and how it works. Conversely, when CloudTrail tracks and records changes made within the AWS config itself, the following APIs are tracked. Delete delivery channel. This deletes the delivery channel. Deliver config snapshot. This sends a configuration snapshot to S3. Describe configuration recorder status. This returns the status of a specified configuration recorder. Describe configuration recorders. This returns the details of a specific configuration recorder. Describe delivery channels. This returns information about a specific delivery channel. Get resource config history. This retrieves a list of configuration items for a specified resource. Put configuration recorder. This creates a new configuration record. Put delivery channel. This creates a new delivery channel for an S3 bucket and SNS topic. Start configuration recorder. This starts recording data for supported resources within your account as per your configuration. And finally, stop configuration recorder, and this stops recording the data. The final service that has a relationship with AWS Config is IAM, and again we briefly covered this in the previous lecture. As AWS Config has relationships with other services, specifically SNS and S3, the use of an IAM role is required to enable the service to publish data to an SNS topic for configuration streams and S3 to store configuration history files and configuration snapshots. The policy for this access would look similar to the following on screen. In addition to this access, AWS Config must also be able to perform the describe, list, and some get API calls against all supported services within the region. As a result, the same IAM role also has a second policy attached which allows access to perform these actions against those resources. That brings us to the end of this lecture of how other AWS services interact with AWS Config. Coming up next, we will start to look at how to manage specific compliance with AWS Config. We briefly touched on this earlier when we looked at the config rules, so we will now look at this in greater depth. Hello and welcome to this lecture where we will begin to look at how to best manage your compliance that you need to adhere to within your AWS environment. Your compliance requirements can come from many different sources. For example, you may have a requirement for your environment to be HIPAA compliant if you're managing healthcare records. Or perhaps your security team requires certain criteria to be adhered to, such as ensuring SSH is not applied to specific security groups. Or your operations team may dictate to you that certain EC2 types should only be used for certain environments to conform to internal standards. Maintaining compliance and internal standards for numerous parties, both internal and external, can be difficult to manage and can lead to mistakes, which in turn will eventually lead to non-compliant services making their way into production. This can be a huge risk from an audit perspective and also from a security stance. AWS Config allows you to utilize config rules to help you manage and organize this compliance, which acts as an automatic resource compliance checker. When a change is made to a resource, AWS Config will check to see if the resource matches a rule with the help of a Lambda function, and if so, it will check the compliance of that resource against the rule following the changes made. There are two different types of config rules within AWS Config: custom config rules and AWS managed config rules. AWS managed rules are a set of predefined rules that cover a lot of best practices, so it's always worth browsing these rules first before setting up your own, as there is a chance that the rule may already exist. At the time of writing this course, these managed rules cover 5 different topic areas: compute, database, management tools, security, identity and compliance, and storage. Do bear in mind that you can edit specific parameters of managed rules within these topics. And so if there is a rule that very closely matches your requirements, then you may be able to edit it by selecting different triggers and parameters to reflect the changes that you need. This can save you a lot of time trying to recreate your own from scratch. Later in this lecture, I will provide a demonstration of how to modify these managed rules, along with how to create your own custom rules. Before creating, modifying and configuring your config rules, you should first identify what compliance and standards that you need to adhere to. Define the requirements from all parties, but remember, there is a limit of 50 config rules per region before you need to contact AWS to request an increase. Let's consider a simple scenario and how these config rules could be used. Let's say we are security architects responsible for ensuring specific security requirements are met in the following deployment. A new web application is being released into the production environment that consists of multi-tiered infrastructure, with front-end web servers in a public subnet, application services with EBS and a back-end RDS database. The application and environment itself is expected to scale with demand both up and down. We have been told that from a security perspective, SSH must not be used for the web server security group under any circumstance. Where used, all EBS volumes must be encrypted. The RDS database must be configured for high availability at all times, and data stored by RDS must be encrypted. Now obviously during deployment we can oversee the implementation and ensure that each of these elements are met. We can make sure the security groups are correctly configured, storage encryption is activated, and that multi-AZ is configured for high availability for the RDS instance. So why the need for these config rules? Well, now let's consider the following. Once the initial deployment was carried out and the security checks were carried out manually, the environment was then handed over to support and operations to maintain and look after. Over time, the application scaled up, additional resources were added, and there may have been some ad hoc incidents and general maintenance of the environment which was carried out. The support and operations team, although they were made aware of the security requirements, they may not have adhered to them at all times, perhaps due to human error, lack of knowledge, or laziness. Your environment now has a situation where some volumes are not encrypted and SSH has been activated on the web server security group, perhaps to troubleshoot an existing incident. As you can see, over time your environment changes, and maintaining the same level of security implemented at the start of the project may not be continuous throughout its lifetime, which leads to mistakes and security holes within your infrastructure. AWS config rules can notify you of these security misconfigurations. If, for example, in this situation during deployment we activated the following AWS managed rules: restricted SSH, which would check whether security groups would disallow incoming SSH traffic. Encrypted volumes, this would check whether EBS volumes are encrypted. RDS multi-AZ support, checks to ensure high availability is configured for your RDS instance. And RDS storage encrypted, and this checks if storage encryption is enabled for your RDS instances. With these config rules in place, a notification would have been sent to the configuration stream stating that a resource had changed its state from being compliant to non-compliant. These notifications could have been configured programmatically to notify your security team, who could have then investigated as to why this had happened, and understand who made the change through the use of the configuration item by utilizing the CloudTrail information recorded when the change happened to the resource. By using config rules, it allows the appropriate action to take place when a notification is received of a non-compliant resource, which may include resolving the security issue identified and ensuring the resource becomes compliant again. Remember, just because a resource is flagged as non-compliant does not mean it is removed from your environment. It will continue to function. Identify who or what made the change. If an employee made the change, advise and educate them on the importance of security and why that resource requires set configurations. If it was a service, check your automation configurations to ensure it doesn't happen again. So as you can see, using AWS config rules allows a continuous monitoring solution for a wide range of uses to ensure compliance is maintained within your environment. The example we have used was a simple security scenario, but the scope is huge, especially when implementing custom config rules. Before we finish this lecture, I just want to provide a quick demo to show you how to select and modify an AWS managed rule and also how to configure a custom rule where I will show you the different elements involved in the process. Okay, so I'm at the AWS config dashboard and at the rules page. So firstly, what we're going to take a look at is how to modify the parameters of an AWS managed rule. So if we go to add rule, and for this demonstration, I'm going to use the desired instance type managed rule. So this checks whether your EC2 instances are of the specified instance type. So we have a name at the top which we can edit if we need to. The description of the rule, it checks whether your EC2 instances are of a particular type. Here's the managed rule name, which is the Lambda function. And here we have the triggers. Now there's two different trigger types here. When there's changes to configurations, or you can have periodic triggers, so at a set period of time. So we got it as configuration changes for this managed rule. Now looking at the scope of changes, this identifies what resources are in scope for this rule. At the minute it's selected resources, and under resources we have EC2 instances. We can also select tags and then add our own tag key pairs in there, so whatever we enter there, the managed rule will only apply to any resources that have those tags within them, or all changes. But I'm going to leave it as resources, so we want this rule to run against any EC2 instances, and then triggered when there's any configuration changes. Now down here we can edit the parameters, so we want to specify which instant types that we want to have running within our environment. Now for our environment, we want to make sure we're just running T2 small instances or M4 large. So just to take a look at this AWS managed rule again, we have the name, the description, the actual Lambda function itself, which is the evaluation of the rule. We have the trigger type, and we've left it as configuration changes. And we have the scope of change. We've selected a resource, so we want this to be based on all EC2 instances rather than specific tags. And then for the instance type, we've edited and added values of T2 small and M4 large. Now, depending on what kind of AWS managed rule you have, there'll be different configuration parameters that you can change. I just wanted to highlight here that you can add your own parameters for specific AWS managed rules. And in this instance, we've added our EC2 instance types here. Now, once you've done that, you just click on save. And then AWS config will go off and evaluate your current environment. And then after a period of time, that evaluation will come back and give you your compliance results. So what I'll do, I'll pause the video here, wait for that to finish, and then show you the results. Okay, so that evaluation has now been completed, and we can see that under our new AWS managed rule, the desired instance type, we have two non-compliant resources. So let's take a look. And here we have our two EC2 instances, both coming back with non-compliance checks. Now we can take a look at these instances. On the far right hand side here you can see manage resource, and this will give us a link to each instance. So let's take a look. So we can see here that this instance type is actually a T2 nano, which is non-compliant with our T2 small and M4 large that we specified in the rule. So if we go back to config and take a look at the second instance, and we can see here that this is a T2 micro, so again non-compliant. So that's the end of this demo on showing you how to edit the parameters of a AWS managed config rule. We'll now take a quick look at how to create your own config rule, which is very, very similar. Okay, so to create your own config rule is very similar steps. Again, click on Add Rule, and instead of selecting one of the predefined AWS managed rules as before, all we do is click on Add Custom Rule. And here you add a number of details, so you can add your own name. So Cloud Academy rule, description. This is a test for a demo. Here is where you'll enter the ARN of the Lambda function that you've created. That will then evaluate your resources to see if they comply with this rule. Now, I'm not going to go and create a new Lambda function because it's out of scope of this course. But for those who are experienced with Lambda, then this is where you'd enter your ARN functions. Now, further down, this is where we add our trigger types, like we just discussed with the AWS managed rules. You can have the trigger to happen every time there's a configuration change or over a specific period. So with regards to the period, you can select 1 hour, 3 hours, 6 hours, 12 or 24. So this rule will run at that set period regardless of if there's any configuration changes. But you can have both ticked regardless. Now, going down to the scope of changes, and again, as we mentioned within the AWS managed rules, it can be against your resources, particular tags, or for both. So if we select resources, we can specify our resource type, for example, VPCs, subnets, security groups. So you can have multiple resource types applying to the same rule. And then again down here, you can have your rule parameters. Here you would define any values that your Lambda function would need to evaluate for this rule. And once you've entered all the information, then all you'd need to do is then just to click on save, and then that will go ahead and create your custom rule with your own Lambda function. And again, it will follow the same process of evaluation and then return any non-compliant results. And that brings us to the end of this demonstration. For a full list of current AWS managed rules that we spoke about within this lecture, then please visit this link. That brings us to the end of this lecture. Coming up next, we are going to look at some different use cases for AWS Config. Hello and welcome to this lecture on AWS Config use cases. We will look at some of the common scenarios of where and why you would want to use this service. In an earlier lecture, we looked at some of the scenarios we are faced with when looking at resource, asset and change management, and how hard it can be to have deep visibility of your infrastructure. Following this, there are a few key use cases for when using AWS Config is ideal within your environment. Let's take a quick look at each. Security compliance. As we learned in the previous lecture, AWS Config can be a great tool when enforcing strict compliance against specific security controls. Being notified of non-compliant resource configurations from a security stance is critical, especially in highly sensitive environments where these controls are imperative to protect both internal corporate and external customer data. Through the use of config rules, you can have the service continually monitor and check your resources remain compliant throughout its lifecycle. Discovery of resources. When you first activate AWS Config or run the configuration recorder, AWS Config will discover all supported resources types, allowing you to view them from within the AWS Config dashboard. A configuration item will be recorded for each, and so these resources could also be found in the configuration history file on S3. Being aware of all the resources you have is key to understanding your environment. You may find that you have EBS volumes out there that are no longer attached to instances, which you could then take a snapshot of to keep the data and then delete the volumes, saving you money. Or perhaps you have subnets configured that no longer have any instances in that you no longer need, and so it allows you to perform some essential housekeeping within your network and VPC. There are many benefits to knowing what you have, where it is, and what it's connected to. Many of these benefits will end up saving you money and help you run a streamlined environment. Audit compliance. As well as using AWS Config for being compliant for internal security standards, there are also many external audit and governance controls where the service can also enforce specific controls on resources to maintain compliance. For example, the Health Insurance Portability and Accountability Act, known as HIPAA, and Payment Card Industry Data Security Standard, known as PCI DSS. These programs require strict controls in many different areas. Being able to set custom and manage config rules in place help adhere to these external governance controls. In addition to this, you could show the auditors all of your configuration history files, which would allow them to go back to any point in time to check the configuration of any of your supported resources. Having this kind of information to hand is essential from an audit compliance point of view. Resource change management. When planning changes within your infrastructure, it's often required that you have an understanding of what effect the change will have on other resources. More often than not, this information is not always known, as you may not have full visibility of other attached resources. With AWS Config, you are able to use the dashboard to list all related resources of a particular resource, thanks to the Relationships section within the configuration item. This allows you to plan your changes more effectively by ensuring all resources that have a relationship to the resource being changed continue to function as expected post-changes. This helps to prevent outages and configurational mistakes being made by having an overall better visual awareness of the environment. Troubleshooting and problem management. AWS Config is a great tool to help you troubleshoot issues that may arise within your environment. Using the config dashboard within the AWS Management Console, you can see a timeline of events allowing you to go back to any point in time. And in the case of an incident, you'll be able to go back to just before it happened. By doing this, you can understand what changes happened on your supported resources. If there were changes made to a resource that is affected by an incident, then this can significantly help you reduce the time to resolution by identifying the possible cause of the problem. You would also be able to see the changes made to the resource and make any amendments to resolve the issue. Not forgetting, thanks to its incorporation with AWS CloudTrail, you can see who or what triggered the change via which API call. If similar events occur frequently, then AWS Config can become a great tool to help you spot potential underlying problems within your infrastructure, allowing you to find the root cause and manage them effectively. You may want to look at some real-world use cases of other AWS customers. If so, then take a look at their customer success stories found here. That brings us to the end of this lecture. In the next lecture, we will summarise what we have learned throughout this course. Hello and welcome to this short lecture where we will briefly look at a high level what we have learned throughout this course. In summary, we have identified that AWS Config is a service within the Management Tools category that can perform a number of useful functions when it comes to resource configuration visibility and compliance, such as capturing resource changes, acting as a resource inventory, storing configuration history for individual resources, providing a snapshot in time of current resource configurations, enabling notifications of when a change has occurred on a resource, providing information on who made the change and when through the use of AWS CloudTrail integration, enforcing rules that check the compliancy of your resources against specific controls, allows you to perform security analysis within your AWS environment, and it provides relationship connectivity information between resources. We also discussed that AWS Config only supports a number of different services and resource types, which can be found here. Another important point is that AWS Config is configured on a region-by-region basis. As such, you can have different resources being monitored and recorded in each region, as you will have a different configuration recorder. We also looked at how the service itself was constructed with regards to its different components, which were identified as follows. AWS resources, the resources in which you want to monitor and record. Configuration items, a record that contains information about the resource, including specific configuration details. Configuration streams, an SNS topic that can be accessed programmatically to extract data. Configuration history. This allows you to view configuration information on a particular resource over a period of time through the timeline within the Management Console or via the configuration history file held on S3. Configuration snapshot. A complete point-in-time snapshot of all your supported resources, including all configuration information. Configuration recorder. The configuration used by AWS Config to determine what resources to record and to which SNS topic and S3 bucket data should be sent. Config rules. Rules that allow AWS Config to check resources compliance against the rule set. Any non-compliant rules are identified and a notification is sent to the stream. Resource relationships. This allows you to clearly identify which resources link to other resources. SNS topic. This is used as the configuration stream. S3 bucket. This is used to store configuration snapshots and configuration history files. And AWS config permissions. The use of an IAM role is required to perform, describe and list API calls to supported resources, along with write access to your selected SNS topic and S3 bucket. Next, we looked at how AWS Config is integrated with other AWS services, such as SNS, where a topic is used as a configuration stream. SQS. This is an ideal service to allow you to programmatically extract useful information from the configuration stream by using SQS as an endpoint within the SNS topic. S3. This is required to allow you to store configuration snapshots along with your configuration history files, which are stored there every 6 hours for each resource type. CloudTrail. This is used as a part of the configuration item to allow you to track the API which created the change on the resource. IAM. This is used to create the role that allows AWS Config to perform its functions as already discussed. We then looked at how to best manage compliance within your environment. Using security as an example, we explained that by using AWS Config, you can implement specific config rules that monitor all changes within your environment, notifying you when a resource becomes non-compliant. This allows you to rectify configuration mistakes, ensuring that your AWS environment is not unnecessarily exposed to weak security configurational changes. Finally, we looked at a number of different use cases of where AWS Config can be used to help support, maintain and optimize your AWS resources. These included security compliance, discovery of resources, audit compliance, resource change management, and troubleshooting and problem management. That now brings us to the end of this lecture and to the end of the course. I hope it has given you a good understanding of the AWS Config service and has left you confident enough to start using the service as you need within your own organisation. If you have any feedback on this course, positive or negative, please do leave a comment on the course landing page. We do look at these comments and your feedback is greatly appreciated. Thank you for your time and good luck with your continued learning of cloud computing. Thank you.